Mark, welcome to South Africa, and it's nice to have you here at the Intel offices in Johannesburg. You're the Director of Strategy for Intel for Europe, the Middle East and Africa.
That's right.
What on earth is that job? What do you do?
Well, Intel's known for processors, we're known for PCs. If you think about a classic PC and you think what's inside, Intel's inside it, with the brain of the computer. But increasingly, those brains can go into other devices. Why can't I have a smarter car, a smarter TV, a smarter display when I go into a retail store to find something? We can make everything smarter. And Intel technology is, I believe, the basis of that. To do that requires a strategy that takes us into segments we're not present in today.
Yes.
But we're working to get into those segments, like smartphones, like smarter TVs, IP-enabled TVs, like smarter cars with in-vehicle entertainment systems that help you navigate and entertain within the car. Those can all be built on protocols that are internet-based and really Intel inside brains. So what I'm looking at is how do we develop that strategy? How do we build out into those new markets? New customers, new competitors, new challenges, new expectations. How do we do that in a smart way? So I'm focused on helping us as a geography, we're IMEA geography, which is Europe, Middle East, Africa region. How do we do that in a smart way? That's my role.
That's fascinating because if you look at where Intel is positioned today and where Intel has come from the past, you look at Moore's Law, and I think Intel have been very much instrumental in bringing the world to where it is today, technologically, with Moore's Law advancing every year and the speeds doubling, and I think it's kind of has it reached a saturation point?
Fair question. I think there are three things that underpin the digital age. One is, can I process information? Secondly, can I store it? And thirdly, can I move it around?
Yes.
So can I process it, store it, move it? What we've effectively done at Intel is, I think, the most complex one, which is processing information. An Intel chip is the size of a postage stamp.
Yes.
And it's got up to 1 billion moving parts on it. But it's very, very small. We produce these incredibly small devices that are very complex, but very clever. And Moore's Law helps us make them smarter, faster, and cheaper, year after year after year after year. Without the ability to do that, you wouldn't have the PC in the home. If we go into downtown Soweto, we went down there 10 years ago, we built a clubhouse. We gave underprivileged kids access to technology.
10 years already?
Up to 10 years ago, yeah. 8 to 10 years ago, I think, if I was to guess the date right.
That's right.
Right? And we went down there and we equipped kids in Soweto with access to PC technology. Now those PCs, 10, 12 times faster in terms of the latest Intel Core technology that we're shipping to the market today. So the reality is these things move very, very fast. But I think it's pretty exciting what Intel's been able to do. We've, in a sense, democratized technology. That everybody gets a vote. Everybody gets the option to own. It doesn't mean that everybody can afford today. It doesn't mean that everybody's going to rush out and buy one today. But if I want to, I can. If I can afford to, I will. And the desire to get on the world's biggest database, the world's biggest library, the internet, and do that and have fun too. I can entertain myself. I can watch movies. I can play games. I can educate my kids. I can help my schools. Those are the things that I think make working for Intel exciting. The young generation are growing up very comfortable with technology. They don't think about it. It's second nature to them. Teachers, next generation, are intimidated by technology. So we started with a very simple place. We said we'll put a program in place, Teach the Future, and we teach teachers to be confident to teach technology to kids that knew much more than them. We've taught over 160,000 teachers in South Africa alone. We've taught 8 million worldwide. Our commitment's to get to 10 million over the next couple of years. We've taught probably about over half a million in Africa, if you take all the countries we've got this program operational in. We're very committed to helping teachers build confidence to help students get the best out of IT technology. So I think our strategy for Africa is to continue to work with governments. We've got to get broadband more actively deployed.
Absolutely.
And that's going to require political intervention. It's going to require working with the telcos, supporting those companies, working with the ecosystem to enable me as a consumer to have reasonable priced access to broadband.
You touched on technology earlier. You were talking about the different aspects, and I remember my first computer all those years ago, and how things have changed. Then how many different mobile devices are there? I'm holding this camera in front of me that you're talking into. There's a processor in this MacBook over here. There's a processor in the cell phones around me. So the processing power is now required on smaller devices, and it's just spreading, and processors are now required in a fridge, for example. So where is it all going?
Well, our commitment, our vision is a compute continuum. So the reality is, in order to make a device smarter, it needs to have a brain.
Yes.
Because it's very hard to be smart without a smart brain. And that's Intel's role. We manufacture smart brains, but not just smart brains in tens of thousands, hundreds of millions of units. There are 6.2 million people on the planet. How can we get more and more of them access to the internet? And how do we ensure that they can connect on any device? Some people are going to opt for a PC or a smartphone or another type of device to get access to the internet. Reality is we've got to make those all have smart brains. So we've put our commitment behind building that continuum. Second thing we've done is we've developed a version of Intel, if you like, a version of Intel inside. We call it an architecture.
Yeah.
Think of an architecture, I can build a 2-story building, or I can build a 5-story building, or I can build a 10-story building. We build architectures that help to build that digital age. We've got a version of our architecture which is called Intel Core, and those are our very smart, fast brains.
Yes.
We've also got a version called Intel Atom, which sounds just like it is. It's the smaller, slightly sleeker, leaner version, more energy efficient, but not as good as best performance as Intel Core.
Right.
Do I want the biggest, smartest brain, or do I want a reasonably competent, good brain? I can put the reasonably competent, good brain in a smartphone. I have the smartest brain in my computer. Combinations of those things allow me to have a digital lifestyle, whether I live in South Africa, whether I live in Munich, as I do in Germany, or whether you live in America or Brazil.
We were just talking earlier, I look at the performance of an iPad, for example, and the other, computers that I've got at home using a quad-core computer, and I look at this MacBook Air. We were talking about this earlier,
yes.
And I just can't believe how they've managed to fit a Core 2 Duo processor in such a small device. Where on earth have they put it, and how have they got this device to deliver such a performance?
Intel worked with Apple when they wanted to develop the MacBook Air. This is going back about 3.5 years ago now. And they said to us, we want to produce the world's thinnest notebook. In order to do that, they needed to get a processor where its energy envelope, its amount of energy it produced, was small enough to enable them to make the notebook thinner and thinner.
Yes.
In order to do that, we had to come up with a customized version of the Core 2 Duo. So we actually did a special version that shrank the processor, which meant it gave off less heat, but it was still the power performance, if you like, of the Intel Core processor, in this case the Core 2 Duo.
Yes.
So we developed a special version that went into MacBook Air, and that enabled Apple to come to market. So in a sense, some element of joint innovation, backing Apple's innovation at the notebook level, led to what became a fantastic product, the MacBook Air. But your first part of your question, smaller devices, that's what's happening. Everything's going smaller. That's why we developed Intel Atom, to enable things to go smaller. And Intel Core to enable things to get more powerful.
Yes.
Combinations of those and now enable equipment manufacturers to design and build fabulous devices. Last thing you mentioned, the iPad. I dream and I would love Intel inside the iPad.
Yes.
Now, that's more fingers crossed because I don't know what Apple's plans are.
Yes.
Today we're not inside. I would love to be inside in the future. Let's see.
And I'm sure it will come. I look at the relationship between Intel and Apple, for example, and other manufacturers. Even on the mobile side, let's talk mobile as well.
Yep.
What's that strategy going forward? Because there are more and more handsets, more smartphones in the world. They're becoming more and more powerful, and they all, are very power hungry when it comes to their processor inside.
You're right. If I take Apple and Intel as an example, Apple is consumer-centric. What does my customer want as the consumer? Intel's a technology powerhouse. We're there to try to force the edge of physical capability. Can I get more and more transistors on this tiny piece of silicon? We're constantly pushing the edges of physics. Apple are constantly pushing the edges of consumer behavior.
Yes.
That combination, I think, is pretty powerful. But equally, we work with a lot of customers, whether it's HP or Dell or Acer, on doing similar types of development. It's all about, we'll bring certain innovation at the chip level, at the brain level, at the extension of that brain into the system. They'll bring expertise on how that whole system is going to work together. That to me, is a powerful set of innovation capabilities. Do it smartly, and the consumer has more choice, more options of device, and I can choose the thing that really suits me. So, to me, the winner at the end of the day is consumers.
Absolutely. And it's interesting that you say that it's the consumer, absolutely, at the end of the day, that drives that innovation forward,
Yes.
with the demands that are made out there. I know that there are some big announcements that are coming up at early part of next year. What can we expect from Intel? What's Intel working on at the moment?
We've taken an element of risk. We've always introduced new technology with a new brand. So my role out in 2008, 2009, I was in our headquarter office in Silicon Valley.
That's right.
And I was working on brand strategy. And we're a little bit like a birthing factory for brands. Because we get a new feature, out pops a new feature, and out pops a new feature, and the engineers say, could you brand it for me? Brands actually stay constant. Coca-Cola doesn't change its color every week.
Yeah.
Apple doesn't change its designs every month.
Nope.
Right? Brands that are stable. Technology constantly changes. How do you reconcile it? We reconciled it by saying Core i3, Core i5, Core i7. The best Intel Core, the most powerful brain. 3 levels, guaranteed. The Core i7 is always better than the Core i5. The Core i5 is always better than the Core i3. We will introduce some new versions of Core, beginning of next year, that will stay in the same brand structure, but the product underneath is going to be better. Much better than you got today. It's going to be better at video, it's going to be better at media, it's going to help you do more 3D stuff. You'll see more of that as we get to the point where we start to announce these products. But I'm pretty excited. For the first time, we're going to have a stable brand. Thank God, I know Core i7 is the best. I don't have to re-educate myself.
Yes.
But you've just made it new and improved.
Yeah.
And when we use new and improved marketing to explain the product's improvement. No difference to shampoo, kids' diapers. The brand doesn't change, the product gets better. We're moving in that direction.
Final question, Mark. What is the one thing that excites you the most that's going to innovate technologically over the next 5 years?
Fabulous question. Human ingenuity. I don't believe there's anything that technology can't solve if we put our smart brains to it. So what Intel's always trying to strive to do is to say, what problems do you have and how can technology solve it? One of the things that drives consumer and business nervousness is security. Is my data secure? Do I trust information I put on the internet? And there's still a lot of distrust, a lot of nervousness. We're looking at how do you make technology make solutions more secure and more accessible and more secure. That is a technological answer. What excites me though is if we can solve those barriers, if you like, the ingenuity that's in people's minds. We're sponsoring a project called the Creators Project, which is how do people use computers to do art and music and turn on the if you like, the creative side of our brains. There's no limitation, I think, to what computing can do. Anything you can do in an analog way, I can take a photograph, take the film, go to a chemist, they produce the photographs, we now do it digitally, and we think, why do we ever get paper printed at a chemist? But we did. Everything like that is changing, and it can change digitally. That to me is amazing. Because it's not down to what Intel does, it's down to people's imagination. And then once we understand what we think they need, we'll try to bring that into hundreds of millions of very smart brains that go inside these devices everywhere. Once you do that and they all connect, it's going to be amazing what we can do. To me, you can dream of what you could do.